Hi everybody, today we're doing BJU Press Pre-Algebra, section 4.3. It's about least common multiples. We're on page 180 in the book. We'll be starting with 1 through 16. Number 1. Determine whether each statement is true or false. A is 20 is a multiple of 4. True. B, 42 is a factor of 7. That's false. 42 is a multiple of 7. Letter C, 6 is a factor of 48. That's true. And letter D, 9 is a multiple of 45. That's false. 9 is a factor of 45. Number 2, for each number, A lists all its factors in ascending order, and B lists its first 6 multiples. So number 2, 12. So A wants us to list all the factors. The factors of 12 are 1, 2, 3, 4, 6, and 12. And then for B, the first 6 multiples. This is going to be 12 times 1, which is 12. 12 times 2, which is 24. 12 times 3, which is 36. 12 times 4, which is 48. 12 times 5, which is 60. And 12 times 6, which is 72. Same thing for number 3, which is the number 30. So A is all the factors. That would be 1, 2, 3, 5, 6, 10, 15, and 30. And then the first 6 multiples, so be 30 times 1, which is 30. 30 times 2, which is 60. 30 times 3, which is 90. 30 times 4, which is 120. 30 times 5, which is 150. And 30 times 6, which is 180. Number 4, list multiples to find the LCM of each pair of numbers. 3 and 15. So in order to list the multiples, we're going to just say, okay, comparing 3 and 15. So multiples of 3 would be 3 times 1, which is 3. 3 times 2, which is 6. 3 times 3, which is 9. 3 times 4, which is 12. 3 times 5, which is 15, and so on. For the multiples, oops, I think I put on here 15, but it's 5. So for the multiples of 5, it's 5 times 1 is 5. 5 times 2 is 10. 5 times 3 is 15. And I'm going to stop right there because I found my least common multiple once I got to the 15. Number 5, 4 and 6. Okay, multiples of 4 are going to be 4, 8, 12, 16, and so on. Multiples of 6 are going to be 6, 12. Oh, I found it right there. LCM is 12. Number 6, for 6 and 10. Multiples of 6, 6, 12, 18, 24, 30. So I'm going to stop there because I already know that the multiples of 10 are going to end up getting me to 30. And that's my least common multiple. Number 7, 10 and 20. Okay, multiples of 10 are 10, 20, 30, etc. I'm going to stop though because 20 is going to be my least common multiple. Once you find it, you don't have to keep going. Number 8. Let me just double check here. Yes, we are doing 1 to 16, all of them. Number 8, use a combined factor ladder to find the least common multiple of each pair of numbers. All right, so a combined factor ladder on 48 and 72. We're going to start with the smallest prime number that divides out of both of them. That's 2. Will leave me with 24 and 36. We can do it again. That's going to leave me with 12 and 18. Then we can do it again. That's going to leave me with 6 and 9. And then here I'm going to have to bump up to 3. So that's going to leave me with 2 and 3. Okay, so this is our prime factorization. When you are looking for prime factorization for the LCM, you're going to be multiplying all of these things. So it's different than the GCF where you just multiply the stuff on the ladder on the side. Now you also have to multiply the things across the bottom. So this is going to be 1, 2, 3, 2 to the 4th times 3 squared. And let me just double check what I have here on my calculator. So 2 to the 4th times 3 squared gets me 144. Number 9, 175 and 245. Okay, so these are not even, and they are not both divisible by 3. So let's start with 5. $175 divided by 5 is 35, and 245 divided by 5 is 49. I can tell right now I'm going to be taking a 7 out of that. That's going to leave me with a 5 and a 7. So LCM, you take these on the side and also these across the bottom. So we have 5 squared times 7 squared, which is going to give me an LCM of 1,225. Number 10, 16 and 96. Okay, so these are both even. Start with 2. That's going to leave me with 8. And then 48. When you are doing the LCMs, if you see something that's higher than a prime number that comes out of both of them, you can just pull it out because you're going to end up multiplying all of them anyway. So I see an 8, which is going to leave me with a 1 and a 6. So this time I'm going to have 2 times 8 times 6, which is going to get me 96. Number 11, 126 and 132. Okay, so let's start with 2. Actually, I'm looking at these here, and I see that they're both even, and they both divide by 3. So I use my divisibility rules to check that by adding 1, 2, and 6, and that gets me 9, which is divisible by 3. And then for the 132, if I add 1, 3, and 2, that gets me 6, which is also divisible by 3. And because they are even and divisible by 3, that means they're divisible by 6. So I'm going to use my divisibility rules here to speed up my process a little bit, which we can do with the LCMs since we're looking for multiples anyway. And then what I end up noticing is that I have a 21 and a 22. These guys are relatively prime because they're next to each other, consecutive integers. So that means I'm not going to have anything else that's going to divide out of either of those. So my least common multiple is going to be 6 times 21. Whoops, get that extra time here. 6 times 21 times 22, which is 2,772. Number 12, use the given prime factorizations to find the LCM of each pair of numbers. So in number 12, in the book, they write 34 equals 2 times 17, and 38 equals 2 times 19. An LCM is found by taking the highest amount of each of the numbers, each of the factors that are there. So I see a 2 in both of them. The highest amount in both of them is a single 2. I see a 17 showing up one time and a 19 showing up one time. So my LCM is going to be 2 times 17 times 19, which is 646. Number 13, it says that 26 is 2 times 13, and 33 is 3 times 11. So my LCM is going to be the highest amount that each one of these factors is showing up. So I see a 2. The most it shows up in these two numbers is once. So I'm going to write 1, 2. Then I see a 3, a factor of 3. It shows up once, and an 11, and a 13. So we end up multiplying all of these to get an LCM of 858. So number 14 is 28 equals 2 squared times 7, and 147 equals 3 times 7 squared. Okay, so the LCM is the highest amount that each of the factors shows up. So the 2 is showing up twice, the 3 is showing up once, and the 7, I'm going to go with the 7 squared because that's the most times that a 7 is showing up. So it's 2 squared times 3 times 7 squared, which is 588. Number 15, 90 equals 2 times 3 squared times 5, and 225 equals 3 squared times 5 squared. So this is what the book tells us. So the LCM is you're going to look at each factor and see what's the most amount of times it shows up between these two numbers. So the 2 shows up once, the 3 squared is the highest, and the 5 squared is the highest for the 5s. So we end up doing 2 times 3 squared times 5 squared, and our LCM is 450. Number 16, explain the processes of finding the least common multiple. So the first thing you're going to do is write the prime factorization. So we write the prime factorization, and then find the product of the highest power of each factor. And find the product of the highest power of each factor. All right, and then we're moving on 17 to 35 odd. Number 17, use prime factorizations to find the LCM of each of the numbers, pair of numbers. So 17 is 4 and 14. So 4 is 2 squared, and 14, I guess we can put equals in here. 14 is 2 times 7. So the least common multiple is found by taking the highest of the 2s and the highest of the 7s. That's going to get us 28. Number 19, 15 and 25. 15 is 3 times 5. 25 is 5 squared. The LCM is going to be the highest of the 3s and the highest power of the 5s. That's going to give us, oh, I skipped one here. That's going to give us 75. Number 21, 42 and 49. All right, so 42 is going to be, let me see, 6 times 7. So 2 times 3 times 7. And then 49 is 7 squared. So the LCM is the highest amount of 2's, which is 1, highest amount of 3's, which is 3, highest amount of 7's, which is 2. That's going to leave us with 294. Number 23, use prime factorization to find the LCM of the given numbers. The least common multiple of the given numbers. So we're checking 2, 4, and 5. All right, so for the 2, it's just 2 because that's prime. For the 4, it's 2 squared, and for the 5, it's just 5. So that means our LCM is going to be 2 squared times 5, or 20. Number 25, 8, 16, and 20. So 8 is 2 cubed, 16 is 2 to the 4th, 20 is 2 squared times 5. So the least common multiple here is going to be 2 to the 4th times 5, which is 80. Number 27, 8, 15, and 18. All right, again, 8 is 2 cubed, 15 is 3 times 5, 18 equals 2 times 3 squared. So the LCM is 2 cubed times 3 squared times 5, which is 360. Number 29, find the LCM of the given expression. All right, so we're adding some variables here. We have a squared, b to the 5th, and a cubed b. So when you're looking at these, you're going to look at the a's, and you're going to take the highest amount or the highest power, which is a cubed. Then you're going to move to the b's, and you're going to do the highest b, which is b to the 5th. Number 31, we've got 9c cubed d to the 5th and 12c to the 4th d to the 7th. Okay, so the 9c cubed d to the 5th is 3 squared. And then the 12 is 2 squared times 3. So now we're going to look at all these factors. Let's start with the 2. Highest amount of 2's is 2. Highest amount of 3's is 2. Highest amount of c's is 4. Highest amount of d's is 7. This is going to give us 36 c to the 4th, d to the 7th. Number 33. Okay, instead of rewriting this multiple times, I'm just going to write my list here. So I have 16. Oh, wait, is that the right one? Nope, that's 34. Okay, so 33 is 10 r cubed s squared t. 25 r squared s cubed. And then 40 s squared t squared. So 10 is 2 times 5, 25 is 5 squared, and then 40 would be, let's see, it would be 4 times 10, so 2 cubed times 5. So I'm not going to write out all the variables every time. I'm just going to do these, and then I'll just look back at the variables to find the highest power of each of those. So for the numbers, highest power on the 2's is 2 cubed. Highest power on the 5's is 5 squared. And then highest power on the r's is r cubed, on the s's is s cubed, and on the t's is t squared. So we end up having 200 r cubed, s cubed, t squared. Number 35, I believe that's, number 35. Find the GCF and LCM of the given numbers. So 36 and 48. So now you're going to have to remember what we did in the last lesson. They put them next to each other because they're very similar. So 36 and 48. I'm going to do a factor ladder on the 36 and the 48. So let's start with 2. That's going to give me 18 and 24. Another 2 is going to give me 9 and 12. Now I'm going to hop to 3. It's going to leave me with 3 and 4. So the GCF only uses these, which is 2 times 2 times 3, or 12. The LCM uses those and also these guys on the bottom. So it's 2 times 2 times 3 times 3 times 4. And that's going to get me 144. Number 42 through 51. Solve each equation or inequality. Y minus 12 equals 49. I'm going to find my equal sign. Find my variable. The y, right now we are subtracting 12 from it. So we need to isolate the y by adding 12 on both sides. That gives me y equals 61. Number 43. Z divided by 3 plus 5 equals 16. Here's my equation, my equal sign. Z is my variable. Right now it's being divided by 3, and then we would add 5. We're going to do the last thing first. We have to do the inverse of the last thing first, which means add 5 was last, so we'll minus 5 on both sides. Z divided by 3 equals 11. Now I can multiply both sides by 3. So Z equals 33. Number 44. Negative x plus 19 is less than or equal to negative 43. Okay, there's my inequality. I'm going to minus 19 on both sides. That's going to give me negative x is less than or equal to negative 62. Divide both sides by that negative. It's really a negative 1. So x, flip your inequality because you divided by a negative, 62. Number 45. Negative 7 is greater than 2b plus 11. There's our inequality. I'm going to minus 11 on both sides. So that gets me negative 18 is greater than 2b. Divide both sides by 2. Negative 9 is greater than b. So we usually like to see the b on the other side, the variable on the other side, and the number on the right side. It's just that if you do that with an inequality, make sure you flip the inequality also. Number 46. Use prime factorizations to find the GCF of the given number or expressions. So 44 and 50. Okay, the prime factorization of 44 is 2 times 2 times 11. Prime factorization of 50 is 2 times 5 times 5. Now remember, this is the GCF, which is different than the LCM. Okay, so you're writing the things that are common, which is one set of 2's. 47. 187 and 209. So the prime factorization for 187 is 11 times 17. And the prime factorization for 209 is 11 times 19. The GCF is the common factors, in this case just 11. 48. 9x cubed y and 12y cubed. Okay, so for 9x cubed y, we would have 3 times 3. Then we'd have x cubed and y. 12y cubed, we'd have 2 times 2 times 3 y cubed. So the GCF is found by doing the common ones. In this case, it's just a 3, and one of the y's is common. Since the 9x cubed y has an x cubed, but the other number, 12y cubed, does not, we can't put an x cubed in at all. So it's just y. Number 49, we have 8a cubed b squared. We have 48 a to the 7th, b to the 5th. 8 is 2 times 2 times 2. And then 48 is 2 times 2 times 3. Oh, I'm looking at the wrong one. 48 is 2, 2, 2, 2 times 3, a to the 7th, b to the 5th. Okay, so find the common ones. That's going to mean my GCF is 8. Out of the a cubed and the a to the 7th, they have 3 in common, 3 a's in common. And out of the b squared and the b to the 5th, they have 2 b's in common. So you should be gathering that when you find the GCF, you're actually finding the smallest amount of common exponents. When you end up doing the LCM, you're doing the largest amount of common exponents. Number 50, Aubrey wants to give a gift to each of her 20 classmates but cannot spend more than $80. How much can she spend on each gift? So let's call it S is how much she can spend on each gift. She has 20 classmates, so it's going to be 20 times S, and she can't spend more than $80. So she can spend 80, she just can't spend more than 80. So as long as it's less than or equal to 80, she's good. Let's divide both sides by 20. That means that she can spend less than or equal to $4. Out of our multiple choice, that means the answer is A. Number 51. Gabriel bought $5 gifts for each of his classmates, spent $18 on shipping, and did not exceed his budget of $150. Which inequality models the number of classmates that he has? Okay, so we would say he bought $5, and the number of classmates is what we don't know. So let's just say that X is the number of classmates. So in this case, it's $5 times each classmate, plus he's definitely spending $18 on shipping. However, all of this does not exceed $150. So this is what our inequality would look like, and I see that in letter D. Okay, that's our lesson for 4-3.